My name is Prudence and welcome to today's class. Now, my area of concentration will be mathematics, physics, and further mathematics. So, today we are going to be doing on mathematics, under which we are having indices. So, let's start with indices. And what does the word indices mean? First of all, the word indices was discovered in the year 1969 by a man called Samuel Jake. So for those of you who can't spell, the word indices is discovered by a man, Samuel Jake, in the year 1969. So you can take this down. The word indices is discovered by a man, Samuel Jake, in the year 1969. So what does the word indices mean? Indices is just the plural form of the word index. I think I should take this slide. Indices is the plural form of the word index. Indices is the plural form of the word index, and or you can call it your exponents, or power. It's just the plural form of the word index, which is commonly known as your exponent or power. Now, what does the word index mean? What does the word index mean? Index simply means that small number you see at the top right corner of a number, of a base number, to say. The small number you see at the top right corner of a base number. Take for instance, now we are having something like 2 raised to the power of 4. 2 raised to the power of 4. Now the 2 here is known as the base number. The 2 here is known as the base number. While the power of 4 is commonly known as the index, or we call it the exponent. Now what does index define when it's being seen at the top right corner of a number? It defines how many times the base number multiplies itself. It defines how many times the base number multiplies itself. Take for instance, now we're having here 2 to the power of 4. What does this power of 4 here simply mean? It simply means you multiply the base number 4 times. It simplifies, you do 2 times 2 times 2 times 2. So that is just the work of index. It's just telling us how many times the base number multiplies itself. So even though we're having here 2 to the power of 6, it's telling us that we should multiply 2 into 6 places. That is what the word index means. Now with this, let's take some few laws of indices and then we'll solve some examples. Let's take some few laws of indices and then we'll solve some examples. Now we have about 5 laws of indices. And the first law comes to the multiplication law of indices. The multiplication law of indices. The first law of indices is known as the multiplication law of indices. Now take for instance, we are having a random variable, let's pick x raised to the power of a, multiplying x raised to the power of b. What does this law imply? It says you should take a common base and then you sum the power. You take a common base and then you sum the power. And let's apply this in terms of real numbers. Let's take for instance, we're having 2 raised to the power of 3 times 2 raised to the power of 2. What do? You take the common base and you sum the power. That gives us 2 raised to the power of 5. And commonly 2 raised to the power of 5 also is known as 32. Now next up, we have the division law of indices. We have the division law of indices. Division law of indices. Now let's also use the same variable. Take for instance, we have been x raised to a divided x to the power of b. What you do here, you take a common base and then subtract powers. You take a common base and subtract the powers. Take a common base and subtract power. Next up, we have the third law of indices, known as the negative power law of indices. Please pay attention here. We have the next law of indices, the negative power law of indices. Negative power law of indices. Let's say for instance, we're having a variable x with the power of -1 here. The -1 here simply means 1 all over this same base number raised to the power. The minus here simply means 1 all over this base number raised to that same power. So this can also be written as 1 all over s raised to the same power, which is 1. Take for instance, now this power is being changed to 2. That is x raised to the power of -2. Nothing changed. You also applying the same idea. That is 1 all over s raised to the power of 2. Also, if we're having, let me say, x all over y raised to the power of -1, what do we do in such a case here? Now, I told you that the minus here simply means 1 all over this same fraction. Now, because here we're having a fraction. It simply is 1 all over this same fraction here, raised to that same power. So here it simply means 1 all over x all over y, the same fraction, raised to that same power of what 1. The minus will just simply means 1 all over that same thing, raised to the power of 1. So this can be written as on your board mass, we have 1 divide x all over y. Now to change here from division to multiplication, what to do? What to take reciprocal. We take reciprocal, we're having 1 times x all over y. Sorry, 1 times y all over x, which can also be written as y all over what x. So you see, that's it. So instead of you to go ahead and simplifying this to this point, what you just have in your mind is that when you're having something like this, you just simply take reciprocal from there. If you're having an expression x all over y to the power of -1 or any other real number, let's say -2 and so on and so forth, you just simply take reciprocal from there. Instead of going through this process and all of that. So now, next law of indices, let me just leave this here. The next law of indices we have the good law. The good power law of what? Indices. The good power law of indices. The good power law of indices. Now, if we're having an expression like this, whereby s is raised to what? A fraction power. The fraction, the power fraction, the denominator at it is known as what? The root power. Yeah, the b now, which is the denominator of this fraction, is known as what? The root power. So we're having the b root of x, the b root of x raised to the power of a. This is what the root power law states. We are having a random variable, let's say x, raised to the power of what? A over b. The b, which is the denominator of the fraction power, is known as the root power raised to the power of a. And lastly, the last law we have here is known as what? The zero power law. The last law of indices we have here, we're taking, is known as what? The zero power law of indices. So if you guys are following me, the zero power law of indices. If it, for instance, we state that anything raised to 0 is 1. Any number raised to 0, or that is an infinite number raised to 0 is 1. So if we're having the variable x raised to 0, 1, even though it's an algebraic expression, let's say for instance 2 is the power of x raised to 4 plus 3x raised to 6 minus 4x raised to 8 plus 4xy raised to the power of 0 also gives us what? 1. So anything at all raised to the power of 0 is 1. So if the right thing, please copy fast. So now we'll take some few questions as we proceed. We'll take some few questions. These are the 5 laws of indices we are going to use, are going to apply in solving problem in today's class. So if you are copy fast, please, because I'm about to wipe. I want to wipe it already. So these are the few laws of indices. So let's take down some questions and provide solutions to them. So I think we're having 3 questions here and I'm very quick. So the first question we have here, it says find the value of the expression. Find the value of the expression where s is equals to -3 over 4. It says find the value of the expression when x is equals to -3 over 4. Now what you just do here, this question is very simple as you can see it now. You just do direct substitution here and then we get our answer by applying some few laws of indices in solving the problem. So what to do here now, let's try solution. Now we did direct substitution now. They've already given us the value of x to be -3 all over 4. So let's do substitution here now. This becomes 32 all over 81. Yeah, our s has the power of 3, so times -3 all over 4 raised to the power of 3, as seen here, minus 64 raised to the power of 2, minus 81 all over 16 times -3 over 4 raised to the power of -3. This power of -3. So let's just work out this bracket. Then we are then having 32 all over 81. Now here, note some, please notice this thing now. When you're having a negative number raised to an odd power, just like 3, our answer will also be negative. But take for instance, we're having a negative number raised to an even power, our answer will be positive. For instance, now we're having minus 3 here raised to the power of 3, our answer will be negative 27. If for instance, we're having minus 3 raised to the power of 2, or rather 4, any even number, our answer will be positive. If we're having minus 3 here raised to the power of 2, our answer will be positive 9, not negative 9. So anytime you're having a negative number raised to an odd power, your answer will always be negative. Why anytime you're having a negative number raised to an even power, your answer will always be positive. So having a negative 27 all over 4 to the power of 3 gives us 64. Minus, let's open another bracket, 64 all over 27 times. I told you earlier, negative 3 to the power of 2 gives us positive 9. And then 4 to the power of 2 gives us 16. So minus 81 all over 16 times. Now what law of indices will apply here now? The law of indices we are going to apply here is known as the negative power law of indices. Where I earlier told you that if you are having an expression from the negative power law, if you are having an expression like this, what do you do now? You take reciprocal instead of simplifying. Because I told you earlier that the negative sign here simply means 1 over that same expression raised to that power, but the negative sign is being eliminated out. Or as long as you are already putting 1 over that same expression raised to the same power, the minus sign is already out. So what you do, you just take reciprocal raised to the same power. You take reciprocal raised to the same power. So if you want to take reciprocal here now, 4 comes up and minus 3 goes and raised to the power of 3. So we're going to have here 64 all over minus 27. That's what we're going to have here, 64 all over minus. You can work it out on your own, but just for space, you can work it out on your own. You just take 1 over this same equation raised to the same power. So let's break down the bracket. So what can go here? 27 here gives us 1. 27 here gives us 3. 62 here gives us 1. 162 here gives us 2. Yes. 9 here gives us 1. 9 here gives us 3. 16 here gives us 1. Why 16 here gives us 4. 16 here gives us 1 also. 16 here gives us 4. 27 here gives us 1. 27 here gives us 3. So what are we having left here now? 1 times minus 1 gives us minus 1. 3 times 2 gives us 6. So having minus 1 all over 6. The next bracket. 4 times 1 gives us 4. 3 times 1 gives us 3. So we're going to have minus 4 all over 3. And for the last bracket, so we're having 3 times 4 gives us 12. On the denominator, we're having 1 times minus 1 which gives us negative 1. But look at outside the bracket now, we're having a negative sign. And from a directed number, I know that when minus multiplying minus, you give us what? Plus. So we're having a negative sign, we're having a negative sign inside the bracket, so that becomes plus 12. No longer minus 12, it becomes what? Plus 12. And what's up next now? We take LCM from here. We take LCM. Now the LCM of 6 and 3 is 6. The LCM of what? 6 and 3 is 6. So 6 divided 6 is 1. 1 times negative 1 gives us negative 1. 6 divided 3 gives us 2. 2 times negative 4 gives us negative 8. And see, here we're having an invisible one here. Please note, we're having an invisible one here. 6 divided 1 gives us 6. 6 times positive 12 will give us positive what? 72. So this will be written as minus 9 plus 72 all over what? 6. So this gives us 63 all over 6, which is equals to, what can go now? 3 can go down and 3 can go up. 3 into the up one will give us 21 and 3 here will give us 2. So this can also be written as a mixed fraction 10 raised to the power of 1. Sorry, 10 raised to what? 1 over 2. 10 1 over 2, sorry. In mixed fraction, this is 10 1 over 2. So either way, you are still correct. So our next question up here, so our answer here is A. So our next question goes like this. If 18 if So our next question says if 18 raised to the power of 12 over 3 times 12 raised to the power of 1 over 3 is equals to 2 raised to the power of m times 3 raised to the power of n. So you should find the value of m plus n. So what should we do here now? There's an idea they want you to have here for this question particularly. There's an idea they want you to have here now. They gave us the on the last and the right hand side we're having 2 raised to m times 3 raised to n. Now normally you should know that if I solve this question now, definitely they are expecting us to have this other side, which is the left hand side, to be in this form before you can get the value of m and n. So let's work it out now. So this becomes, what can we multiply to have 18? What do we multiply to have 18? We can have what? 9 times 2. 9 times 2 gives us what? 18. Please note that should be in factor of 3 and 2. Note that there should be in factor of 3 and 2. That is the way we can simplify this so that this order, the left hand side and the right hand side, will be equal, they will be the same. So now, what can we multiply to give us 12? Remember, there should be in the factor of 2 and 3. So somebody will say 6 times 2 gives us 12. But if you use 6 times 2 to give us 12, you won't be able to break it down so that it will be in this form. But if you're having 4 times 6 to give us 12, you can 4 is to the power 4 now can be expressed as 2 to the power of 2, which gives us the expression now has been in this form. So you should take note of that. So here we're having 4 times 3, 1 over 3, which is equal to 2 raised to n times 3 raised to n. So what's up next now? We express it in the power of 3. So this becomes 2 raised to the power of 2 times 2. 2 over 3 times 2 raised to the power of 2 times 3, 1 over 3 is equal to 2 raised to the power of n times 3 raised to the power of n. Please, we are writing, please write fast. So what's up next now? You use this power outside to multiply each base number power inside of the bracket. To open the bracket, you use the power outside to multiply each of the power inside the bracket. So for a 3, I'm going to have 3 raised to the power of 2 times 4 over 3 gives us 3 raised to the power of 4 over 3. For a 2, this is 2 raised to the power of 1. Because definitely 2 raised to the power of 1 also gives us 2. So this is 2 raised to the power of 1 times 4 over 3. That should be 2 raised to the power of 2 over 3. This bracket has been opened. For the other side now, this is 2 raised to the power of 2 times 1 over 3. That is times 2 raised to the power of what? 2 over 3. For the other side, this is 3 raised to 1. You know that 3 raised to 1 also gives us 3. So that becomes 3 raised to 1 times 1 over 3. 1 over 3. This is equal to 2 raised to the power of n times 2 raised to the power of n. You can see now, things are falling in place now. So once you apply the multiplication law of indices here, the 2 families comes together and 3 families comes together now. So this becomes 2. Multiplication law of indices states that, please don't forget, when we're having a common base, you take one base and you sum the power. This becomes 2 over 3 plus 2 over 3 times the 3 family comes together. Take a common base also and then also sum the power. That is 4 over 3 plus 1 over 3. And on the right hand side, we're having 2 raised to the power of n times 3 raised to the power of n. So let's work the power. Our SN here is 3. 3 divided 3 gives us 1. Multiply by 2 gives us 2. 3 divided 3 gives us 1. Multiply by 2 gives us 2. So 2 plus 2 gives us what? 4. See. Also the SN here is 3 and same thing happened. That gives us what? 5. Equals to 2 raised to the power of n times 3 to the power of n. So you see the idea now. Both the right hand side and the left hand side are what? The same. They are what? Equal. And when two things are equal, means they equate each other. When two things are equal, you can what? Equate each of them. So you see now the idea here is this now. We equate each term, both on the right hand side and the left hand side. We equate each term. See both the right hand side and the left hand side are the same. So we equate each term. So here we are having 2 raised to the power of 4 over 3. Which is 2 raised to the power of n. And then we are having 3 raised to the power of 5 over 3 is equals to what? N. So 3 is n, sorry. So 3 strike out 3 and 2 strike out 2. So what's left here is that we're having 4 over 3 equals to n, which in turn can also be written as m equals to 4 over 3. Since that was equal. So n now is equals to what? 5 all over 3. And the question says you find the value of what? N plus n. So this becomes therefore n plus n will then be equals to 4 all over 3 plus 5 all over 3. This becomes 9 all over 3, which is equals to what? 3. So that is the answer. So let's take our last question and we'll close for today's class. Let's take our last question and then we'll close for today's class. So our last question says you should simplify. Simplify 25 minus 1 over 2 times 27 1 over 3 plus 1 2 1 over 2 please minus the space times 6 to 5 minus 1 over 4. So this is our question. This is simplify this now. So what I'm going to do is just this is as easy as just applying the basic laws of indices and then you arrive at your answer. There is no work in here, there is no too much work here. So just apply the laws of indices here, as easy as that, and then you get arrive at your answer. So 25 is the power of what? 1 over 2. From your negative law of indices, you remember that 25 is the power of from the negative power of indices. You know that when we're having a negative power here, what is the negative sign is 1 over that same number. The base number raised to that same power. So now 1 over 2 is also known as square root in indices. 1 over 2 is what? Square root. 1 over 3 is cube root. 1 over 4 is fourth root. And that is how it goes. And that is how it goes. So 1 over 2 is also known as what? Square root. So in essence, what this means 1 all over the square root of what? 25. Yes. 1 over the square root of 25 times 1 over 2 is now the cube root of 27. And what the cube root of 27 plus, now we can put this in brackets. This having a positive sign here means that what? Different. So here we're having a negative power here, so we take 1 over the square root of 1 to 1. 1 over the square root of 1 to 1 times also a negative power here, 1 all over the fourth root of 6 to 5. 1 all over the fourth root of 6 to 5. Hope you are following. So what's up next now? Square root of 25 is what? 5. That is 1 over 5. The cube root of 27 over 3. You can push your calculator for that. Cube root of 27 over 3. Why did I say the cube root of 27 over 3? 3 into 3 places here. I told you that exponent there define how many times the base number multiply itself. So 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. That's how I arrive at this answer. Plus square root of 21 is what? 11 times 1 over the cube root of 6 to 5 is 5. So what's the next now? So this now same addition is what's called multiplication. So multiply here gives us 3 over 5, and on the other side we're having 1 all over 55. 1 all over what? 55. So at this point, what we do now is that we take LCM. The LCM of 5 and 55 is 55. Because why? 5 is a factor of 55. So since 5 is a factor of 55, the LCM of 5 and 55 is what? 55. 55 divided by 5, that is 5 into that is I think 11. Why? Times 3. 55 divided by 5 is 11 times 3, give us 33. Sorry for that mistake. 55 divided by 55 is 1, multiplied by 1 gives us 1. So this becomes 34 over 55. Thank you and enjoy the rest of your day.